Hi everyone. In this class, we will discuss about the long-term deflections in prestressed concrete members. These long-term deflections occurs over the time. In a earlier video, we have discussed about the short-term deflections. The short-term deflections are the deflections which occur immediately after the loading, or the deflections which occur immediately after pre-stressing. That's why short-term deflections is equal to sum of deflection due to pre-stressing force plus deflection due to loads. But these long-term deflections occur over the time. It might be due to creep of concrete and shrinkage of concrete, and relaxation of steel. Due to these reasons, there will be a loss of prestress in steel. Loss of prestress in a steel or pre-stressing steel or tendon. Okay. See, this creep and shrinkage are due to the creep and shrinkage will be in concrete. This relaxation of steel is due to the loss of stress in the steel with the time. If you want to determine total long-term deflection we may call. I am denoting with AT. AT is equal to initial deflection multiplied by 1 plus pi plus deflection due to shrinkage of concrete. Here pi is equal to creep coefficient. Means the ratio of creep strain by the ratio of creep strain to the elastic strain. Creep strain to the elastic strain is known as creep coefficient. ACI is equal to deflection due to shrinkage and loss of prestress. ACI is equal to deflection due to shrinkage of concrete and loss of prestress. AI is equal to initial deflection. Already we know this one. Initial deflection is equal to deflection due to pre-stressing force plus deflection due to load. Right? How you are clear? Total deflection is equal to initial deflection times 1 plus p plus deflection due to shrinkage and pre-stressing steel. In sometimes shrinkage and relaxation effects are neglected. In that case, total deflection is equal to initial deflection times 1 plus pi. This deflection due to deflection due to shrinkage, and the prestressing tool is neglected, then the formula will be AI times 1 plus pi. AI times 1 plus pi. If you want to discuss the deflection terms of curvature, as we know, suppose this is the prestressing member. Due to instantaneous deflection, it may bend like this. Right? It may bend like this. But due to the application of loads, and creep and shrinkage, these are the long term deflections. This load will apply in downward direction, and it tries to decrease this curvature, right? Hope you are clear. This load tries to push the curvature. It may leads to decrease the camber, but creep causes the deflection to increase with the time. Deflection may increase with the time, while shrinkage causes loss of prestress, which in turn reduces upward camber, right? This shrinkage will increase the camber, but this creep and load decreases the camber. Means deflection due to live load is downwards, and deflection due to creep is downwards. Deflection due to shrinkage is upwards. Okay. Problem C. Here there is a post tension roof girder spanning 30 meters. L is equal to 30 meters, and it is an unsymmetrical I section with moment of inertia is given as 72490 multiplied by 10 power of 6 mm power of 4, and overall depth of the section is given as 1300 mm. See, here the section is parabolic. The effective eccentricity of group of parabolic cable at center of the span is 580 mm toward the soffit and 170 mm toward the top of the beam at support. It means that here the tendon profile is like this. This is CGC. The tendon profile is like this. Eccentric at midspan and eccentric at supports as well. At center, the eccentricity is given as what is how much eccentricity is given? Eccentricity parabolic at center is 580 mm. Eccentricity at center is 580 mm, and eccentricity at supports is this one. This one is 170 mm. Prestressing force is given as 3200 kilonewtons, converting into newtons. Okay, and self weight means dead load is given as 10.8 kilonewton per meter and live load is given as 9 kilonewton per meter, right? Modulus of elasticity of concrete is given as 34 kilonewton per meter square, mm square. Creep coefficient is 1.6. Total loss of prestress is C. Loss is given. Loss of prestress is equal to 15%. Now they are asking to estimate instantaneous deflection or short term deflection, and also asking long term deflection allowing loss of prestress and creep. We need to consider both creep and loss of prestress. We will try to solve this problem. First, what we need to do for this type of tendon profile. First, this type of tendon profile, the short term deflection is delta P is equal to, short term deflection is sum of deflection due to prestressing force plus load. That's why the formula is PL square by 48EI times minus 5E1 plus E2. P is given as 3200 kilonewtons. That's why into 10 cube. Length is given as 30 meters into 10 cube whole square divided by 48 into modulus of elasticity is 30, modulus of elasticity 34 kilonewton, 34 kilonewton per mm square. Converting into cube, newtons, multiplied by moment of inertia 72,490 into 10 power of 6 multiplied by minus 5. Here in this formula we are assuming this is E1, this is E2, right? E1 is equal to 580 plus E2 is equal to 170. By solving all this one, deflection is 74.7 mm. Here I am taking a negative. Negative means upward. Generally, prestressing force will be, when we apply the prestressing force, it will go upward. It will move upward. That's why upward. Deflection is upward, a minus sign. Next, we need to determine deflection due to both loads. Deflection due to self weight plus deflection due to self weight plus deflection due to live load. Sorry, deflection due to self weight only. Then the formula is 5. What is self weight? How much self weight is given here? 5 W L power of 4 by 384 times EI. That is equal to in question they asked only instantaneous deflection due to prestressing force plus self weight, right? That's why I'm taking only self weight. I'm not taking a live load there. Why? Because in question it is clearly mentioned that only self weight. 5 into, what is the self weight given? 10.8. 10.8 into, converting kilonewtons into kilonewtons into newtons and meters into mm, then 10 cube by 10 cube, right? Length is given as 30 meters, 30 into 10 cube whole power of 4 divided by 384 times E value 34 into 10 cube multiplied by 72490 times 10 power of 6. By solving this one, we may get 46.2 mm. This deflection due to load, deflection due to self weight will be downward. Am I right? Downward. It is downward. Downward means plus, right? Now we need to sum the both. Total deflection is equal to total short term deflection is equal to minus 74.7 plus 46.2, that is equal to minus 28.7 mm. Minus means upward. Now IS 1343 recommends that this value, this upward deflection should be less than, as per IS 1343, this upward deflection should be less than span by 300. That is equal to, what is this span? Span by 300 means span is 30 meters. 30 into 10 cube by 300. That is equal to 100 mm. Right? 28.7 is less than 100 mm, so it is safe. It is safe. Now we need to determine long-term deflections. Long-term deflection is equal to deflection due to creep plus deflection due to live load plus deflection due to shrinkage or loss of prestress, right? Deflection due to creep is 1 plus pi times instantaneous plus deflection due to live load plus deflection due to creep is, if the loss is given, then we can substitute here. See, right, 1 plus pi value is not given directly, but instead of giving pi value directly, instead of giving pi value, pi value is given directly, no issue. Pi value is given. Pi value is 1.6 times instantaneous deflection. Instantaneous deflection is 46, right? Instantaneous deflection is 46.2 plus deflection due to live load. Deflection due to live load we didn't determine the deflection due to live load. Deflection due to live load is equal to 5 WL power of 4 by 384 EI. We know this formula, where W is, we used the same formula, 5 WL power of 4 by 384 EI, but there we used W means dead load. Now we need to use live load here. How much live load has given? Here they have given the live load of 9 kilonewton per meter. 9 kilonewton per meter. 9 kilonewton per meter. Converting kilonewton times length is 30 meters. Power of 4 divided by 384 times modulus of velocity 30. Modulus of velocity is given as 30. Modulus of velocity 38.4 into 10 cube plus length is moment of inertia is given as 72490 multiplied by 10 power of 6. By solving this one, the live load deflection due to live load is 38.4 mm. Deflection due to live load is always downwards means negative, right? Now substitute this value, it is minus 38.5. now deflection due to shrinkage. It is generally the shrinkage is caused by sustained load, means dead load. How much loss is given? The loss is given as 15%. Loss is given as 15%. That means 0.85 times deflection due to dead load. Already we have determined the deflection due to dead load. Deflection due to dead load is calculated as 46.2. Now deflection due to long-term deflection is equal to what is the value? It is 95 mm. Right. As per IS 1343, this value should be less than span by 250. See, for upward deflection it is limited to span by 300. Downward deflection it is limited to span by 250. That is equal to, span is 30 meters divided by 250. That is equal to 120 mm. Right? 38.5 is less than 95 mm is less than 120 mm. So it is safe. This is the way to solve this problem.